Hello everyone, this is Amarnath Swami from GMIT of Technology. Today, me and my friends Hemant, Devika, Megha are discussing about the solar energy and solar photovoltaic system, that is nothing but SRTPV system. Hey, where does this light come from? There must be some energy required to produce this light, right? Then, what is the source of energy which is converting into light? That is nothing but electricity. We all know that according to Newton's first law, energy can neither be created nor be destroyed but can be transferred from one form to another. In this case, the electricity produced is converted into the light energy. Then, now coming to the point, how this electric energy is produced? As I said, according to Newton's first law, energy is transferred from one form to another. In the similar way, electrical energy is converted from many of the natural energy resources. In that, few of them are wind energy, tidal energy, solar energy, thermal energy, and also geothermal energy. Now, coming to the straight away for our topic, in the present world situation, solar energy is a very flexible, renewable, eco-friendly, and economical source of energy. Solar energy can be converted into electrical energy by installation of solar panels.
The most commonly used renewable source of energy is solar energy. But how does solar energy converts into electricity? A PV system or a photovoltaic system is used to convert solar or light energy into electrical energy. The basic component of PV system is called as solar cell. A single solar cell can produce 0.5 volts of electricity. A solar panel or solar module is a combination of several solar cells connected in series to generate enough electricity that can be used. More the number of solar cells, more will be the solar panel voltage. For example, 30 solar cells can produce 15 volts and 16 solar cells can produce up to 30 volts. Combination of solar panel connected together is known as solar array. How does solar cell work? Generation of electricity on exposure to sunlight is known as photovoltaic effect. Hence, we call it as PV system. Solar cells are made up of semiconductors, mainly silicon, and comprises of 3 layers. The top layer is called as N-type layer. It is thin and contains more electrons. And the bottom layer is called P-type layer. It contains more holes or positively charged particles. These 2 layers the 2 layers combine to form a p-n junction. In this, the electrons in N-type material tries to reach the p region, carrying a negatively charged layer. Similarly, the holes in the p-type material tries to reach the n region, creating a positively charged layer. And this region is called as depletion region of semiconductor, which contains neutral atoms. Sunlight penetrates easily through the top thin layer. Protons from the sunlight, when hit the neutral atom in this depletion region, it splits into electrons and holes. When these electrons move towards the positively charged layer and leaves the system,
This region is called the depletion region of semiconductor, which contains neutral atoms. Sunlight penetrates easily through top thin layer. Photons from the sunlight, when hits the neutral atoms in depletion region, it splits into electrons and holes. Then, these electrons move towards the positively charged layer and leaves the system. The holes are attracted by the negative layer and forming on electronic circuit and producing electricity.
Installation process. Basically, there are 5 steps of installation process. Step 1. Which direction should solar panels face? Solar panels should be in north-facing direction in southern hemisphere. For northern hemisphere, solar panels should be in south-facing direction. India lies in northern hemisphere, so solar panels should be placed towards south direction, and also it can be installed in east or west direction. Step 2. In which angle we should install solar panels? Solar panels tilt angle from the horizontal should decided according to the latitude of your location anywhere in the world. In India, different tilt angle are used in different areas and are classified into 4 zones. The states like Jammu and Kashmir, Himachal Pradesh, Uttarakhand, the tilt angle is 30 to 36 degree as zone 1. The states like Rajasthan, Uttar Pradesh, Delhi, Haryana, Bihar, northeastern states, the tilt angle is 24 to 30 degree as zone 2. The states like Gujarat, Madhya Pradesh, Jharkhand, West Bengal, Maharashtra, Chhattisgarh, Orissa, the tilt angle is 18 to 24 degree as zone 3. The states like Karnataka, Tamil Nadu, Andhra Pradesh, Telangana, Kerala, the tilt angle is 12 to 18 degree as zone 4.
Step 3. How to mount solar panels. The distance between the two pedestals is shown in table. The minimum size of PCC foundation should be 300 into 300 into 300 mm. Once the solar structure is fixed accurately, connect it with solar modules and then ensure that all the nuts and bolts of the solar modules fixed with solar structure.
Step 4. Connection of solar panels in series or parallel. When solar panel is connected in series connection, it increases the velocity in order to match it with battery bank. And if the solar connection of solar panels is connected parallelly, then it maintains the voltage of each panel.
Step 5. How much area should be needed for installation of solar panels?
Module size of each 250 solar panel is 1.0 meter into 1.6 meter. 1 kilowatt panel requires minimum 12 square meters or 108 square feet shadow free space.
Let us look forward for the benefits of the solar panels. Though large-scale installation accounts for 87% of solar power generation, today the adoption rate of solar rooftop panel is accelerating. There are many benefits by installing the solar panels. In that, few of them are cost saving. The biggest advantage of installing rooftop solar panels is that they offer cost savings. The tariff rates of rooftop solar is comparison to industrial and commercial tariff rates are cheap by 17% and 27% respectively. For building owners, rooftop solar installation can ever help in cutting down the electricity bills. It is a secure investment. As compared, electricity prices keep on fluctuating from time to time, so it is difficult to calculate the expenditure on electricity for a certain period of time. However, when it comes to electricity generation by solar rooftops, the price of power generated can be calculated easily. In fact, one can even calculate the cost of electricity generation for another 10 years. It increases access to energy. Though the deficiency of power in India is decreasing rapidly, still there are many people both in the rural and urban areas who have improper and unreliable access to electricity. These people are forced to rely on alternatives like diesel generators. These alternatives pose harmful effects on the health and they are volatile in terms of their operating costs.
Support from the government. In order to encourage people to adopt solar energy, the government offers tax credit to those who install rooftop solar panels, whether it may be for residential or commercial purpose. Reduce carbon footprints. Solar panels harness sunlight to generate electricity, so they pose lesser pollution risk to the environment in comparison to the conventional source of energy. Unlike a generator, they steam without producing any noise and give out lesser emission of harmful gases.
Low cost maintenance cost. The chief factor of rooftop solar panel is that they require very less maintenance cost. Suitable for Indian climate, rooftop solar panels utilize sunlight to convert it into electricity. India is situated at an ideal geographical location and receives ample tropical sunlight. It doesn't require additional space for installation. It is one of the biggest advantage of rooftop solar panel is that they can be installed on any type of roofs.
Now coming to the Pradhan Mantri Awas Yojana. You may be thinking about what is Pradhan Mantri Awas Yojana. It is a solar subsidy scheme where the government will pay 30% of the total amount of the installation cost. The solar rooftop project. It is the project that will be installing the solar on the rooftops. This will help the country in producing the renewable resources. Official website, cost of solar power generation, benchmark cost provided by CFA, solar unit that are being promoted. These values are given in this table. Now coming to the futures of solar subsidy scheme. The government has announced that it will be giving a subsidy of 30% to the general category of stages and union territories. The rooftop installation is not just for the rural areas but for all sectors and institutions. Example, hospitals, social and government institutions, etc. Now we will see how we can apply for the solar power subsidy. By using these two link address, we can apply for the solar subsidy. And this is the application where you need to fill and apply for the solar subsidy. Now coming to the specifications of the panels. The area required for the installation of panels is about 100 square feet per kilowatt. When coming to the cost factor, it varies about 60,000 to 70,000 rupees, and the installation cost is calculated as per the addition of 30% subsidy offered by the government installation cost of rupees 42,000 to 49,000, and these are the information of specifications of panels.
Now, at last, coming to our institute. There are unique features of GM Group of Institution SRTPP grid tied system. These are, our institute is the first institute in Karnataka which has got highest installed capacity SRTPP system, South India's second institute. Since September 2016, the institute has been self-reliant in energy and producing around 5,000 to 6,000 units per day. Institute is generating 5 to 7 times the electricity they consume and fulfills the electricity to the entire campus. Institute is saving approximately rupees 2.8 to 3.4 lakhs of electricity bill per month, other than exporting power. Number of units generation is about 3,000 to 600 units per day. Solar panels are installed on the roof of admin block, girls hostel and PU college in GMIT of Technology. All the specifications of installation of solar panels and the electrical energy produced are shown in the table. In our institute, SRTPP system at GMIT campus can prevent 30 tons of carbon dioxide, 0.21 tons of sulfur dioxide and 10.6 tons of fly ash and 1 ton of particulate matter compared to thermal power plant of 1 megawatt.